for the second screencast of the year, we're going to be talking about a part of a graph that we're called intervals of increase, decrease, and constant intervals. Okay? Now, all we're talking about here is whether the graph is going up or down, or is the graph flat. So take a look at what I've defined intervals of increase to be. It's the part of the domain, in other words, your x values, where the function or the y values are increasing. In other words, it looks like it's rising from left to right. Remember, we always read a graph from left to right. So it looks like we should have what we would consider to be positive sloped values for this graph, right? Well, intervals of decrease are parts of your domain where the function has, where the y values are decreasing. In other words, it should be going downhill or have negative slope values. And the last one is constant intervals, where the graph is just flat or it's horizontal, right? Or you think the slope is 0. Turning points are where you go from increasing to decreasing or from decreasing to increasing, right? So again, just as a helpful idea, take a look at this graph right here. Suppose I have this red function right here, and I want to talk about the intervals of increase or decrease, or constant, right? Well, imagine me. Let's draw a little picture of me here somewhere. Okay, here I am. You see me down here? Imagine me walking along this red graph as if I'm climbing mountains and whatnot. If I'm starting to climb here, would you say that I'm increasing or decreasing right here? Are my y values increasing right here? So this would be an interval of increase, right? Now, as I get to the very top of this graph, what's happening? Well, I stop increasing, don't I? Right? When I'm at the very top here, at the very top of this mountain, I'm not increasing or decreasing. But then as I go to the other side of the mountain, don't I start going down? Well, because I'm going downward, I would say this is an interval of decrease. Well, I stop going down right here, and then I turn around, and I start going back up again, right? So this again would be an interval of increase. So does it make sense that the tops of these mountains and the bottoms of these valleys, well, those are what we call these turning points, right? So these are turning points, what I like to call TPs, not toilet paper, but turning points, right? Those are my TPs, right? My turning points where I go from increasing to decreasing, or decreasing to increasing. And then where I'm rising is my interval of increase, and where I'm falling my interval of decrease. So let's write this out formally. My intervals of increase. Well, again, these intervals are x values. So where is this graph going uphill, or where am I rising? Well, it looks like to the left of this value of what looks to be 1, negative 1, to the left of negative 1, I'm increasing. So how do I write that in math? Well, let's use inequalities. Again, because intervals are about x values, for all x's less than negative 1, the graph is increasing, right? Now, let me erase this real quick. What's happening at negative 1? Am I increasing or decreasing? Well, let's take a look at this. If I was standing at the very top of that mountain, would you agree I'm neither increasing or decreasing, right? So, if the question is, should this be inclusive or not? The answer is, that'll never be inclusive. Because I'm no longer increasing at the top of the mountain, right? So, these intervals of increase and decrease are never inclusive. They're just less than or greater than, okay? All right, where else did we say I'm increasing? Well, I think we said after this turning point, I'm increasing, right? So from this value, what looks to be maybe 1, to the right, I'm increasing. So where am I increasing? I'm increasing at x is less than negative 1 and at x is greater than positive 1. So that's my intervals of increase. Where am I going downhill? Where am I decreasing? Well, it looks to me as though I'm decreasing between negative 1 and positive 1. So since I'm talking about, again, these intervals being x values, all my x's between negative 1 and positive 1. And again, that compound inequality is a between statement, okay? All the x's between negative 1 and positive 1, right? All right, now, the next thing. We said that these are my turning points. Well, we want to talk about what kind of turning points each one is. Does it make sense that since this turning point is at the top of the mountain, I'm going to call this guy a relative maximum. Now, the reason why we say it's relative is relative to this centralized location, he's the highest value that we see. Similar to, the relative maximum of the United States would be Mount McKinley in Alaska, right? Which means that's the highest mountain in the United States. Now, is that the highest mountain we have in the world? No, we know that, Mount Everest is the highest mountain overall. But the relative maximum for the United States would be Mount McKinley, right? Okay, so I know that this value right here is a relative maximum, and I would say that the maximum value for that would be the highest y value that it's reaching there, right? So let's take a look at this. So the turning point is the point where the graph changed from increasing to decreasing. So that is definitely going from increasing to decreasing. And I said that my maximum value is just the y value, okay? So the maximum value at that point would be at 0, right? My maximum value is 0. And that's a relative max. Again, you only give the y value. Now, is there a relative minimum? Yeah, it will be right here at the bottom of this valley, right? So it looks like the relative minimum value, the y value for that turning point, would be at, say, -4, rounded to the nearest integer, okay? And so that's my relative max, my relative min, all right? Let's do it one more time. Take a look at this graph. In this graph, let's see, I've got, 3 different things going on here, right? So, where would you say that I'm increasing or decreasing and whatnot? Well, would you read from -5 this way, it looks like I'm going downhill. And I stopped going downhill right here, right? So this is definitely a decrease, right? Okay, is there anywhere else where I'm decreasing? Yeah, I think I'm decreasing right here, from here this way. Would you agree? So these are two intervals of decrease. And that would be all my x's less than -4. And I'm decreasing right here to the right of 2. So all the values greater than 2. And again, you don't put the equal signs. Never put the equal signs. Where am I increasing? Well, it looks like I'm increasing from -4 to 3. Right? So all my x values between -4 and -3 is where I'm increasing. Am I increasing anywhere else? Am I increasing here or am I just staying flat? That's staying flat, isn't it, right? So you're neither increasing or decreasing there, right? But I am increasing from 1 to 2 again, right? So I'm increasing between -4 and -3, and also between 1 and 2, okay? So again, these answers tell me what values of x am I going uphill or downhill, all right? Now this last one, again, at this point on from this stretch of graph right here to here, would you agree I'm neither increasing or decreasing? I'm constantly setting. So we say that from -3 to 1 is where the graph is constant. So between -3 and 1. Okay? And those are the intervals of increase, decrease, and constant. Now, what about turning points? Where do I turn around from going up to down or down to up? Well, this bottom of the valley right here is definitely a turning point. This top of the mountain right here is definitely a turning point. And right here, let me just point something out. You see where we go from increasing to constant, right, or constant increasing? Those are not turning points. Turning points have to be tops of mountains and bottoms of valleys, okay? Right? You have to be going from increasing to decreasing or decreasing to increasing. Never constant, okay? Now, what would you call this? Would this be a relative max or a relative min? Does it make sense why, again, locally, this is the lowest we're going to go, so this is a relative min, right? Okay? This one will produce a relative max, okay? Now, what is my relative minimum and relative max? Remember, they're only the y values of my turning point. So my minimum values, my relative minimum values will be, it looks like, be -2. And my relative maximum value is 4. Right? Why aren't they the overall minimum and maximums? Well, if you look at these arrows, see these arrows at the end? Doesn't this imply that this graph goes up forever and goes down forever? So there is no true overall minimum or maximum since the graphs go up and down forever. All right? But they do have a relative min and max. All right? Well, I hope you understand how to write intervals, how to figure out the intervals of increase, decrease, and constant, how to figure out what a turning point is, what kind of turning point it is, and what the minimum or the maximum value is. I hope that was quick. Talk to you later.